Hello, I'm Billy Hoffman from Rigger. On this edition of Web Perfectionist, we're going to take a look at caching API calls in web applications. So I was doing some analysis of Granger the other day. Granger is a big industrial supply company. They're actually a Fortune 500 company. They're huge. You've probably never heard of them. But even though you might think industrial supply, selling belts and cables, how sophisticated can they be? These guys are actually super sophisticated. They're using HTTP2. They're using CDNs. They're appropriately caching. They're doing all sorts of great stuff. And so that's why it was really intriguing when I was looking through these tabs of Rigger optimization, where we analyze your site for over 300 performance issues. I noticed they weren't caching some content. They definitely have some content that's expiring too soon, but they actually had some content that was just flat not being cached. And specifically what I was looking at were these 4 JavaScript files. Now, one of the things we do is we display the last modified date that we get from the server to give you an idea of, hey, here's something that's not being cached, but here was the last time it was changed, to kind of give you an idea of how long you could conceivably cache something for. And what we see is there's no last modified date with these things. And if we actually click in, what we find is that these are not JavaScript files. They're actually JSON responses. They're actually JSON responses to API calls that the JavaScript makes when you're browsing this page. And if we actually look at this URL, we see that it's product table view. If we come over here, there's actually on this product page, there's these tables of different length or number of ribs or thickness on each of these belts. And they kind of are dynamically loading this data in via an API call. If we actually look at a waterfall chart and filter out to just things made by XHR, we can see these 3 requests. Now, here's what's strange. I'm going to go ahead. I won't disable caching, but I will reload the page, and we'll find that the browser will re-request those same things again. So it's not caching those responses. And sure enough, if we click in here, we see that there's no last modified date, there's no E tag, and there's no expires. So it's not caching any of this information, and sure enough, it's reloading it every time, which is really kind of silly because I'm not logged into Granger. I have no state with Granger. These API calls really are just to dynamically load in this content. You could have very well just done this as part of generating the base HTML page. They're just kind of lazy loading the content in. But this content's not changing. And sure enough, this content is actually the same regardless of what visitor is visiting the site. So you could not only cache this in browsers, but you actually could cache this in intermediate caches. But we see that they're not doing that. That's kind of strange because if you go to this Yahoo article from literally 2007, our old friend Steve Souders, this is one of his original 14 rules, is to make, he calls it Ajax cacheable, but really what he's talking about is using Ajax XML HTTP request from JavaScript to fetch basically API calls, get data, and execute on it, which is exactly what's happening. So almost a decade ago, this is about 9 years ago, Steve was talking about doing this. And sure enough, we see a really sophisticated company is forgetting to do this. Now, the insult to injury kind of gets added when you start interacting with these tables. So let me clear this up. I'm going to go ahead and I'm going to sort this data table by industry number. And we can see an API call was made. I'm going to go ahead and actually sort it again. We make a call for, so in this case, it was order descending. In this case, it's order ascending. And then let's go ahead and click this again. And we can see that, yep, sure enough, it's refetching it. It's fetching the same content over and over and over again. And you'll notice it actually is putting a time date stamp. That little underscore equals, that is actually the number of seconds since the Unix epoch. You can see it only changed a little bit from 98 to 99. So we clicked it pretty fast. So they're putting a time date stamp on these, but that's silly because they're automatically increasing that time date stamp every single time, which even if they were caching would change the URL. So they're doing a number of things here to basically not cache this, but that's silly because if I'm interacting with this page and I'm, sorting by, thickness of belt back and forth, right? I'm probably going to be, toggling these columns back and forth and back and forth. And at least at the JavaScript layer, they could be caching these objects, but might as well just leverage HTTP and cache the HTTP level. There's no reason not to do this. It's actually pretty easy to do. It's just a matter of you can go ahead. You could unconditionally just say, hey, expires. Here's a response, expires for 5 minutes, right? Much like you would do far future for a logo, you could do that for these API calls because, I'm not super up to date on the volatility of the Dayton V or 4L V belts market, but I'm guessing these prices aren't fluctuating like commodities on a stock exchange, right? So you could probably cache this for 5 minutes. I don't think it's changing rapidly. And basically improve the experience of users as they navigate around in the pages or they interact with the pages. So that's the performance optimization I want to talk about today. Steve's advice from 9 years ago absolutely still applies. You can cache calls to APIs, especially when the data has no state or no authentication information associated with it. It's a great optimization to do then, and it's still a great optimization to do now.